Hello, in this video I'm going to show you how you can quickly define your own apparent data types in the CPL code on ProxySG, what is also known as the header byte or the magic byte or the file signature byte and so on. Essentially is the first two bytes. I mean, usually it can be more, but usually it's the first two bytes in any payload send over TCP socket that you can use to identify what is the underlying file type that is being served. So the ProxySG is kind of capable to detect file types on 3 different levels, as most proxies are. First one is the file extension from the URL path. So for example, if you go to something like this, let me just quickly open a new browser tab. If you do something like this and you do file.txt, right, so this is a URL, and in the this bit is something that the proxy can recognize. So it looks for dot followed by a string, and it can identify that. So it comes with a predefined list of strings, which start with a dot, are followed by a number of different characters, such as JPEG and PDF and exe and text and so on, and the proxy can identify them as file extensions. Now, this type of file detection method is the one that is the easiest to spoof by anybody, right? Because all you have to do is, I guess, remove the extension on your server and serve the file just like this without any extension, and you will be able to kind of bypass the underlying policy that maybe says, hey, if the extension is .exe, block. The second way, of course, to detecting the file type is using the MIME or the content type http response header. So this can still be spoofed. I suppose if you are admin on the server, you can easily write a piece of code into the virtual server, or a HTTP access file where you kind of say that, well, if somebody asks for this particular file, you want to say that the content type header is going to be HTML and text, rather than an application octet stream, which will be the case for an exe file. So in this video I'm going to be talking about the third way, which I guess is the best way, but it can still be spoofed, but it's a lot harder, and that's the magic byte. So to demo that, I've got a internal Apache host here with directory listing enabled here, and I've got 3 files here. So I'm going to be using these 2 for the demo. So the first one is an actual real exe file. I'm going to before I do that, I need to just quickly make a couple of policy changes here. So let me disable this guy, and okay, and let's now download the file. And okay, let's also disable this for now because we don't need it. I don't need that for this demo. Okay, here we go. So let's download the file, and yeah, already exists. I want to replace it. That's fine. Let's look at the file. So let's open it in Notepad. Now these are the first 2 bytes of this file are MZ. So MZ is the magic byte, the parent data type, file in header for all the executables. So every time you download in a executable, it's going to start with MZ. So if I now jump into Wireshark and I'm going to run a Wireshark here on my transaction, and I'm going to request the file again. Yep. And I'm going to now look at the Wireshark. So let's just follow this TCP. In fact, I don't think I need to, because you can already see that here. So you can see also the 2 bytes, the magic byte. Perhaps I can zoom in a bit more here. You can see them here as well, right? MZ. So I'm going to pause this. Here is me. What it will probably be best if I follow it, follow the TCP stream, right? So here is me doing a get, right? So I made the get to this. I got a response 200 OK. This is the actual file being served here, right? And if I go, so this is the file being served here. It's, I don't know how many megs, but it doesn't fit in 1 MTU. So of course it's streamed over the TCP socket until I get the 200 OK here from the server, from the proxy that kind of says, hey, I served the entire file, and the Wireshark does the very nice job of kind of decoding the fact that that's the last byte. The entire file has been served and acknowledged, and we get this HTTP 1.1 200 OK here. This is the content type, by the way. You can see it here, right? And you can also see the content type. Oops. Let me click on that again. There's a slight delay there for some reason. You can see the content type here, right? So application X MS-DOS program. Now, the same magic byte is seen here as well, right? Again, MZ. If you hover your mouse over these 2 bytes, you actually see it in this slide representation here as well. So this is the, I guess, the ASCII representation, while as these are the actual values of the bytes. So the M is 4D and the Z is 5A. So the ProxySG come with predefined set of apparent data types, magic bytes, call it what you want. It's not a finite list, right? To have a look, I'm not sure if they are all listed here, but if you Google the CPL guide for the proxy, you can look at apparent data. So here you go, the parent data types. Oh, they are actually listed here. So these are all the ones that Blueco/Symantec/Broadcom has predefined or in the SGOS code for you already, so you don't need to bother with writing the code. You just use this equals, and you pick basically one of these values, right? The problem, of course, with this is that this is not the finite list. However, it is a very good list that has got, I would say, all the file extensions that you would need. But if you find yourself in a situation where you need to do some policy decision based on file types, and you don't want to do it on extension or content type, because like I said, they are easily spoofed, you want to be doing it on the magic byte and it's not in this list, you can create your own. In the old version of SGOS, you could actually see how these were defined by the Blue Code engineering team in the prologue on the proxy. So if you jump to your console, well, either console or like SSH connection to your to your proxy. Let's go to command line, and you do show sources policy, and then build. Oops, I guess I made a typo somewhere. No, I didn't. Build in Prolog. So I am on SGOS 6.7, so they no longer list here them here. They are hidden now, but in 6.5, 6.6 and 6.7 you could see the magic bytes being actually defined here, right? So the engineer has defined it in a Prolog for you, and then you could then use this CPL to point to that variable that was basically defined in the Prolog. And the way it was defined in the Prolog was like this: response.data. So the ProxySG is capable to look, I want to say 64 bytes, I think, I could be wrong. I think it's 64 bytes inside the payload. For obvious reason, it can be looking into the entire payload, because I don't think that it's the right place for the proxy to be looking at the various integration with content analysis, DLP, and so on for appliances that are specifically built to be actually making decision on the payload. The proxy was designed to be making decision on the TCP socket itself, on the protocol, and on the metadata, rather than on the actual payload. So things like the request header, the response header, port and protocol and socket, and then the SSL handshake, ciphers and certificates, so on. So if we look at this CPL code here, this gives you the option to actually inspect the payload. Like I said, I think the maximum is 64 bytes, so you can use the n here value to sort of tell the proxy how deep you want to look. So for our demonstration of the exe file, all you need to get is the is to put value 4 there, right? So we're looking into the first 4 bytes. In fact, we could get away with the first 2. And then you've got the option to use any of these, right? So what I have done, I have used the regex one, and I basically taken this pattern, pattern of 4D58, and defined it as a reject in the CPL code. So if I now jump into my here, I'm going to make this a little bigger. So I actually manage this box on Management Center. So here is the local file, and here is the code, right? So I have defined a condition here. I called it exe, parent data type. This is, by the way, just for demo. There's no need of doing this because, like I said, this is already one of the existing one that Broadcom has defined, right? But there you can see there is the regex 4D5A. So, and now I've got a rule here for it, which is commented out currently with a semicolon here. So this my browser is going, my Firefox is going via the proxy. So if I get the file right now, I am allowed, as you can see here, right. Let's save this. Yes, all right. I've got 200 OK. The file is served here. I mean, I have saved it to the hard drive. So what I'm going to do now, I am going to uncomment this line. I put a policy deny there. I've got an allow here, but it's within the same layer, so I don't think that I've got anything else that allows it, but I can run a policy trace on it as well, just in case, to make sure that to make sure that there's nothing else in my code, and let's install this to my box into the local slot and install. Yeah, I've got some warning, we know about them. If I now go into my test here and I grab it, there you go. I am blocked. I know for fact that I matched my rule because I have actually added the string into that rule as well. You try to download an exe and this is against policy. I have now got a 403 forbidden here. The response here is the exception page, right? You can actually see it, defined here. The exception page, this is the string that I have injected into the HTML, body of the page. If I now go into the policy trace, let's do a refresh here, and I jump here. This is the transaction, is the only one I made. This is not a very busy proxy. The only thing I would point in there is the Firefox. Here is the requests that I made, the matches I made. These are all variables that are defined in the prologue, again, not defined by me. And my rule, the deny rule, is right here, right? So I got a match on this rule. The first 4 bytes indeed equal to this. We already know that from the Wireshark pcap and from Notepad MZ, right, as we can see here. And I am serving the false deny exception. I am put in this extra string there just so that I know that it is the rule. And it says here, indeed it was denied, either denies or false denies was match, blah 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 blah. Now this is all great. However, as with everything, you have to be aware of false positives, so I kind of wanted to capture that in this video as well. As you could have probably guessed by now, there's probably a ton of other payloads that could start with MZ very in the first 2 bytes. Now a very simple test is a text file that starts with the 2 characters MZ. So what I have done here, if I just go to my, if I go here, I've got this dummy not exe.text. So as you can see, I get blocked by the same policy. If I put my filter back in here and I restart the pcap again, and I re-grab this not exe file, and I now stop the Wireshark, and here is the file. Let me actually follow it again so we don't get any other clutter, right? So there's the file I have requested, I got blocked. There's the exception page. Why was I blocked? Because when you look at I need to find this at the right place. It's because that's already the deny. Am I going to be able to find it here? I don't think I am. No, I am not, because the proxy has replaced it already with the exception page. So what I'm going to do is I'm going to do this so I can show it to you. Where is it? I am going to make a change here. I'm going to comment it out for a second so you can see that it has got MZ in it. Save this, yeah, foo, and let's install this to my box. And is the Wireshark running? The Wireshark is not running, so I'm going to run it again. And I request the same file. This time I'm going to be allowed. You can actually see browser can render a text file, right? So I put inside the text file MZ, and if you look at the Wireshark also, now you will see. Let's follow this guy. and you know, you can see it here, right? MZ. And if you look, you know, here, there is the pattern that we match in a regex, right? 4D58MZ. So we matched it and we blocked a text file just because it had the two, you know, characters, or the two, you know, letters of MZ. So we got a false positive. So the lesson learned, I guess, is to, you know, be careful when you are defining this magic byte by telling a proxy to look into the payload, because you could end up you know, blocking text files or other payloads that are actually not, you know, executable files. So while it is the best method from the security, you know, perspective, because you can't easily bypass it, you would somehow, you know, have rapid or base 64 encode the entire exe file, which then means that if your user was to download that, you know, that file, the user wouldn't be, you know, able to run that file. You would have to decode it or do some, you know, manipulation with the file to get back the you know, exe file out. And that concludes the demo. Thank you.